Okay, my name is Cindy Kelly, and I am in South Denver, Colorado. It's June 25th, 2013, and I'm with Fay Cunningham. But the first thing I'm going to do is ask him to tell us his name and spell it.
Fay Cunningham, F-A-Y-C-U-N-N-I-N-G-H-A-M. It's a good old Scottish name.
Hey, the Scots are great. Any rate, tell us something about your background.
Okay. Well, I was born in Lansing, Michigan in 1922. My parents were from northern Michigan, and my father was an automobile worker, and they managed to, in the 20s, while business was still good and he was making cars and working, we bought a small 3-acre plot out in the country then, and put it into an orchard and berries. And this was our salvation, and a big garden. This was our salvation through the Depression, because we had so much food and fruit, and we had chickens. Later we got a cow, so we had milk and eggs, and we spent the summers harvesting all of this food that we were growing and then preserving it by canning it. Freezing was not heard of in those days. And then we would live on that in a root cellar, which put the root plants or food in, and store apples and potatoes and so on to get us through the winter. Started high school. I went to a grade school a half mile from home, and it was a K to 8, and then I went to a junior high for 1 year for the 9th grade, and then Lansing Eastern High School for 3 years to finish up. And I graduated in January of 1939. I was 16 years old. No money, no job, no prospects for a job. My father had been, the worst of the Depression was over, so my father was working fairly steady. Then we were making automobiles. He had switched over for Real, where he had been working, because he could see it coming that they were going to quit making cars and concentrate on trucks, which they did. And he switched over to Oldsmobile, and he worked there the rest of his working life. But as soon as I turned 17, I joined the CCC, and I went up in northern Wisconsin. I became a crew chief right away of a timber cruising crew. We were basically inventorying the forest for lumber and harvest of trees. The camp was a soil conservation camp. The Soil Conservation Service ran the place in the daytime. There was an army ran the camp, provided the discipline and the food and the clothing and so on. It was a wonderful experience because everybody learned to work as a team and a work ethic. You did it or else. And so it was good. And I stayed in 8 months. You sign up for 6-month increments, but you can get out if you got a job or going to go back to school. I was one of the few guys in camp who had even finished high school. And I had good grades all the way through and so on. So anyway, the forester that I was working for, reporting to him, was really urging me to go to start college. And I could live at home because Michigan State had an excellent forestry school, and Michigan State was in East Lansing, only about 8 miles from our home. So I could live at home, which would help. And my mother got a civil service job, so she didn't need They didn't need the $22 of my $30 a month salary, and they had deposited it in the bank for me. So I used that for my tuition the first 2 terms. Tuition at that time was $40 a term, and that included all the athletic events and an excellent concert and lecture series and all kinds of benefits. Then after about I was in 1940 that I started at Michigan State, and in the spring of '41, I kind of ran out of money, and I had a chance to get into Oldsmobile, working in the motor plant and the engines. So I dropped out of school to get some more money, and I stayed in until Pearl Harbor hit while I was working there, and I can proudly say that I bolted the crankshaft onto the flywheel on 50% of the 1942 Oldsmobiles. There were 2 shifts. And, then after Pearl Harbor, I was real patriotic. My father had been in the Navy, and my great-great-grandfather had been in the Navy in World War 1812, so I decided I'd join the Navy. But they flunked me because of my left eye, which was fairly astigmatic. And so I decided I'd go back to school for a while, which I did, and I switched to engineering. I liked the forestry, but I didn't see much of a future in it. There weren't that many jobs, and I thought engineering was here to stay. So I switched, and I got laid off at work, of course, because the plant shut down a week after Pearl Harbor, and converted to guns. And along in May, they called me back to work, so I went back to I decided to go back because there was a much better job and more pay, and they'd arrange it so I worked the midnight shift all the time, which wasn't too popular, and so I could do it, and some other people liked it. So I did that, and I was machining tank cannon, actually, putting the lands and grooves in the tubes with a long broach, and I worked from midnight to 8, punch out at 8, go home, shower, jump in the Model A Ford I had, a 31 Model A then, and drive out to Michigan State, go to class all day, and go home at 4 o'clock or so whenever I was done, and I'd study a little bit, and I'd go to bed about 6 or 7 and sleep till 11 and get up and go to work again. So I did that for 2 terms, and I got pretty burned out and quit. And I just went on to school. In '42, the Army came up, so they decided they were going to need a continuing supply of engineers. So I joined a program they had called, you joined the Enlisted Reserve Corps, the ERC. It was for medical students and engineering students. And the idea was at the time when you stay in school till you got a degree, then you could go in the Army and do whatever they needed you to do. And it sounded pretty good, so I did that. And but after a couple more terms, the Army, in its wisdom, decided that they were going to need bodies more than they needed engineers. So they called everybody up to active duty. Well, I'd had a couple years of ROTC in the field artillery, so I went to field artillery basic at Fort Sill, Oklahoma. And I was in a sound ranging group there. I had all the tests that we took when we went in the Army. I'd kind of aced the Army General Classification test, which was the the placement people said they'd never seen anybody with that high a score. So that helped me the rest of my career in the Army, of course. And anyway, they put me in. That was the most technical thing they could do. We picked up the sound of enemy guns on microphones that were surveyed in, so we knew the grid coordinates accurately of the microphones, 6 of them. And then they were wired into a sound machine, which was accurate, would plot anything up to 1,000th of a second, which is pretty fast or a short time. And the time interval between it hit each of the 6 microphones, from that, with a lot of sophisticated trigonometry and taking into consideration the curvature of the Earth and all kinds of things, and using 7-place log tables, because all we had was slide rules and they didn't work for that. But we'd come up with the coordinates of the source of sound and give that to our artillery, and they'd hopefully take them out before they moved. But it was kind of a cat and mouse game. But at any rate, I finished that, and the company commander wanted me to apply for West Point. I had kind of mixed feelings about that, but I decided I would, and he was quite insistent. And so I got over there, and they flunked me too, of course. I had a nice interview. I think I did well, but my eye was not adequate for their purposes. And so I went back to, well, then you want to be, the Army, in its wisdom again, decided they're going to need engineers after all. So they had a program called the ASTP, Army Specialized Training Program. And he insisted I apply for that, which I did and was accepted. And I went to a unit at Oklahoma A&M, which is now Oklahoma State University, in Stillwater, and to a unit called a STAR unit, Specialized Training and Reclassification. And they tested us for about 4 days, and then they meditated a while. Anyway, I got sent to the University of Maryland to mechanical engineering. I had wanted chemical, and that was my first choice, but I got my second choice, which was mechanical engineering at the University of Maryland. So there were 3 basic engineering groups, and they were people right out of high school or had no college at all. And then the advanced group, you had to have 2 years of college, and which I had just barely had, but I got in that, and there was 3 terms of that. Well, after 2 terms, the Army decided they needed bodies again, so they called everybody up from the basic program, just shut it down, called them all up, and they called most of the people in the advanced, but they did leave it at certain schools where the president of the university was a good politician or something. And anyway, Maryland fit the bill, so we stayed on, and then in fact they added another term, so I had 4 terms, in other words, a full year, not just an academic year, but a full year. And we finished up, we were all wondering where we were going to go. When we finished, we didn't have a degree quite, but we were almost there, and we had a certificate of finishing the Army Specialized Training Program. And in midterm of the last term, we were interviewed by about half the class. So there was 30 in our group of engineers, mechanical. There was an electrical group too in Maryland. But the 30 of us, about half of us were interviewed. And so when the orders were posted, 9 of us were to report to the Special Engineering Detachment Corps of Engineers in Oak Ridge, Tennessee. And what's that? And some of us, there were 9 of us selected for that. The rest of the group went to the combat engineers. Half of them went to Europe and were building bridges under fire, and about 6 weeks from the time they left campus. The rest went to Okinawa, and they were running heavy equipment trying to rebuild the harbor because we bombed it and destroyed it before we went in. And we got to Oak Ridge in Knoxville, and the Army bus met us there and went out to military base at Oak Ridge. It was a military reservation. And we had to stop to be checked by the MPs on the way out and so on. And then we found out the next day what we were going to do, and my assignment was to be a K-25, going into training to be a shift supervisor because the plant was running obviously 24/7, 365. And I just got into it about 3 weeks, and one morning when I got up, I got called to go over to headquarters, and the sergeant handed me train tickets to Boston, and I was going to be in charge of the three of us that were going. One of them was Kermit Lundell, who had been with me at Maryland, and the other one was Bill Smith, who had been in the ASDP program also at Nebraska, University of Nebraska. Then, so he was telling us what to do. When we got to New York, we would phone a phone number. And he said, I said, oh, I thought we were going to Boston. He said, how'd you know that? He thought there'd been a leak or some sort. I said, well, because you gave me tickets to Boston. And he said, oh, yeah. And, so anyway, we went to New York, and I phoned the number, and we were told to get a cab and drive down and come down to some number on Park Avenue, which was the headquarters of the Manhattan District, actually, and of the Engineer Corps. And then a sergeant would meet us there and pay for the cab because we didn't have much money. And we were all PFCs, $54 a month, and a board and room, of course. So he told us that we were going to have a second. We went up to the headquarters there, and they sat us down and told us we were going to have another FBI check, and we'd have to stay in New York till that was completed. So there we were in New York City, first time for all of us. Well, no, one fellow, Bill Smith, was from Paterson, New Jersey, just across the river. But Kerm and I, was our first time in New York, and we, but here we were with very little money, and we had to have boardroom. We were on rations and quarters, but we wouldn't get paid till the end of the month. So the sergeant told us about a church right near there and we had to check in every day, that had cots in the basement, and we could stay there. It was free, and also they had breakfast for us, so that was pretty good. And we both phoned home and had our parents send us some money to tide us over because we were the same thing when we got to Boston. Well, we were there about 3 days, and we had a chance to go to the big high point was probably go to a Frank Sinatra concert. We got tickets, and we were the only men in there practically. It was all girls and women screaming and yelling, standing up on their seats so you couldn't see. But it was interesting. But we managed to get to some of the museums and take a ferry over and learn the subway system a little bit. Had a good time. But so we took the train up to Boston then once we got the clearance. And the same thing there. We phoned a number, and the guy they told us to stand in front of the drugstore there, so we did. And with our barracks bags and stuff, and pretty soon a civilian, relatively elderly, civilian came over and wanted to check our papers, and so we showed him, and he said, "Come on." So we went out and got in a big car and went over to the Boston headquarters of the Boston district of the Engineer Corps. And there we went in and we were told that we were going to be working at MIT in a metallurgical department. That the metallurgical department had a contract with the Manhattan Engineering District to provide a lot of basic metallurgical research. And that was it. And that we'd be working in civilian clothes. And they gave us a $150 credit. And guy took us to a clothing store and we bought civilian clothes. Well, 150 bucks even in those days didn't really fill it out. So once we got set up and established, we rode home and had a lot of civilian clothes sent to flesh it out. And then we went to next morning we went to the MIT and met with the department, the head of the department, John Shipman, and he'd been at the Met Lab in Chicago before, and then when the opening came there, he took that opening. So he was the head of the engineering project, metallurgical project there at MIT, as well as the department head of the university, at the university part of it. And my assignment and Kerm's were to, MIT had the contract also to provide the crucibles that the uranium and plutonium were reduced in at Los Alamos. The fissionable material comes out of the separations and purification processes in an oxidized state. The UF6 had to be reduced to the metal, and there was a high temperature reduction, and it needed to have crucibles to do it in, and MIT was providing them. Well, they were having trouble. They had ceramic engineers to handle the firing part of it, but when they tamped the crucibles, they were tamping them by hand, and when they were fired, they would tend to slump or have irregularities in the porosity and so on, so they'd be rejected. They were getting about a 20% acceptance, which was not tenable really for the long haul. So our job was to mechanize this somehow to make it so it was more uniform, and so we'd get a better acceptance rate. So we assembled all kinds of equipment, and we had priorities on materials and parts, air hammers, mixers, and feeders, and vibrating feeders, whatever we needed. We had priorities to get it, which was very important during the war because there wasn't much of anything available regularly, but you had to have a priority. Well, we had it, so. And anyway, we worked all fall, the fall of 44, in the winter, spring of 45. And along in the spring, we had the thing perfected to the point that it was working, and our acceptance rate was 80% instead of 20, which was acceptable, really. So at that time, I got transferred to the Beryllium project, and the technicians kept on grinding out the crucibles using this machine to tamping them and firing them in a big brick oven at 1700 degrees centigrade. So I didn't have anything more to do with that. Well, unfortunately, the Beryllium their job was to enhance the physical properties of it so that it would be easier to machine into it was part of the trigger mechanism of the bombs, and or any nuclear reaction actually, and it would store up neutrons and then use them to bombard the fissionable fissionable materials and get them started. It was quite important that that be done right, of course, because you didn't want it going off too early and you didn't want it going off too late. So anyway, you had to, and they had to make these into rather unique and difficult configurations. And it was the metal as it comes out of there is hard to machine, and then it gouges easily and galls easily. So our job was we were heat treating and cold treating and extruding them and pressure hammering them, doing everything you could to try to change the crystal structure. And I was doing a lot of the metallography, where we'd pull it and test the strength, physical strength, and then also we'd mount it in a plastic thing and then polish it and grind it to get it smooth and take pictures of it, get to see what the crystal structure was like. And I went through a microscope, and that's what I was doing a lot of the time. But I got to do all of it, really, at one time or another. And in the process, I was exposed to a lot of beryllium dust and fumes when we were melting it and pouring it and grinding it and polishing it and so on. And then the war ended about that time. And we found they dropped the bomb, and they came around and told us right away that we could tell people what we were working on, but no details, of course. And of course, my parents had always wondered what the heck I was doing. And Jerry, we weren't married, but we were semi-engaged, I guess. And we corresponded regularly, but she had no clue as to what I was doing either. And nor did anybody that I met there at MIT or outside of our group. And they had actually had people going around and kind of tested you. And, you know, it was fair game to ask us how come we weren't in the Army or something, you know. And we'd all cooked up a story. I'd hurt my knees at football at the University of Maryland and got medical discharge, which was not true. But I did hurt my knees, but not that bad. And they fortunately had given us discharge pins to wear, which was very helpful because you get on a streetcar or bus or something, you'd be the only guy on there between the ages of 18 and 40 maybe. And all the rest were women or elderly men or kids or something. You get a lot of funny looks. And but anyway, we had to survive that. But then in September of '45, we went back in uniform. They decided that we didn't need to be in civilian clothes anymore, so we went back. Well, that was a lot better because we could get some of the benefits of being in uniform on, right, financially wise, train tickets and so on and so on. And but that was, and I continued working with the beryllium thing, and we were making some headway along in the spring of May. I never did hear how it came out. And I was working on that. My roommate was working with beryllium oxide, and I never had any clue as to what he was doing, and he didn't have any clue as to what I was doing. And we roomed together for a year and a half almost. And we had, at first we'd stayed in dorms, but our rations and quarters just wouldn't cut it. And so then we went to lived in a fraternity house, which they were low on occupancy in their houses. They'd rent them out cheap and provide food cheap relatively to the university there. And then later we got an even better deal. We got a studio apartment with was $35 a month. So we was $17 a month apiece, and we were getting, I think, about $50 for room. So which could get you much of a room normally. But so then when along in the spring of 46, we had somebody came up from Oak Ridge and was pleading with us to waive separate. We were all by then eligible for discharge. They had a point system to get out of the Army. And the ones that were overseas got 2 points a month, and in the States you got 1. And we didn't get any for the part of the time we were at MIT, because we actually were employed by MIT part of that time. So we were kind of the last people getting out, which was all right. We weren't digging foxholes and sleeping in the rain, so I never had any objection to that those guys get out first. But anyway, I was about ready to get out, but everybody was getting out, and they'd already gone or was getting out in the SED, and they needed radiation monitors for the upcoming Operation Crossroads, the Bikini test, the Bikini Atoll, and there were 8 of us there at MIT in the military, and the rest were all civilians, professors and assistant professors and so on, and technicians, and some of the technicians were veterans that had come home and got medical discharges. And so in the Army there's an old maxim: never volunteer for anything. And we violated that, but the 4 of us, there were 8 of us in the group, and 4 of them were married, 4 of them weren't. Well, all the single guys opted to go to Bikini, put off discharge for 3-4 months, whereas the other guys all opted to get out of the Army, which was all right too. And we went to Oak Ridge and got some training on instruments we were going to be using there, which were newer models and grades than the ones we had at MIT. And I'd worked some with uranium there. They had project there too. And I'd worked some with uranium there, but not a lot. But anyway, we got about 2 weeks training, and then we shipped out on train Pullman car had a tour across the country, and got to Oakland Army Base and boarded the USS Haven, which was a hospital ship. That was going to be our base for the radiological safety section. And the reason that we had that ship, that's the only Navy ships, the hospital ships, that were air conditioned. And it wasn't for us, it was for our Geiger counters and other instruments, because they didn't have a chance to make them tropic proof. And in fact, they had a lot of maintenance problems even as it was. But we could store them every night, supposedly, in the air-conditioned ship. And we got out there, and turned out my job was to be on an initial boarding team. It was 10 men on it, and I was the only Army man. There was a Marine photographer, and the rest were all Navy brass, headed by a Navy captain and 2 commanders and a couple of lieutenant commanders and a bunch of little lieutenants to make it up. And they were all specialists of one sort or another. One would be naval air, and another one would be ordnance, and another one would be Bureau ships, a structural part, and so on. And our job was to board the target vessels as soon as possible after the blasts and get a quick survey of the damage in the event they were sinking or going to sink or something, and to see what the status was, whether it was safe for other people to board them at all. And then we'd get off. We didn't stay on them very long. We'd go to another one. But And so there were 2 tests at Bikini, Operation Crossroads. The first one was an airdrop. We had about 60 ships in the target array, and they were anchored in the lagoon at a arrangement such that there'd be damage from complete damage and destruction down to practically none. And our job was to board these vessels and get a quick survey of the damage, physical damage and radiological damage. And my job was the radiological part, and I advised the captain how long it was safe to stay, and he'd cut that back a little. Everybody used their own safety factor. And so we did that. And then the second test, well, then in between, there were a number of ships sunk. And we went out on day jobs out from the haven. We boarded these vessels from a naval net tender. It was a seagoing tug that's designed to handle submarine nets that are used in the harbors to keep submarines out. And they'd open and close the gates with these things and lay the nets and retrieve them and so on. They had a couple of horns up on the front, kind of like a crane, but the steps going up, and we could go right up, and they'd step sometimes right from the horns into the deck of the. And sometimes we went up a Jacob's ladder, iron rungs welded on the ship. Sometimes we boarded a landing stage and get up. Other times we would have to climb up a cargo net. I climbed up. The most difficult one was a free-hanging cargo net over the bow of the Independence, an aircraft carrier. Here I'm carrying a 15-pound suitcase model Geiger counter in one hand. And I had a smaller one that I could put in my cargo pants. Our Army fatigue pants had big side pockets. I could put that in there. So I had one hand to climb this net. And I'd hook my finger on when I'd move the hand to the next on the net. But it was tricky. And the only equipment, people always ask me what kind of equipment we were issued to, protection equipment. They gave us each a pair of leather gloves, and they were so stiff you couldn't use them because you couldn't operate your instruments with them. We never did use the gloves, and otherwise we just with our Army boots and Army fatigues and so on, and no special precautions of any sort. Then there was a lot of residual radiation on some of the ships because they did get a tremendous neutron bombardment. For instance, the neutron bombardment would create radioactive potassium or sodium in soap. The bars of soap would be radioactive because they'd been bombarded by neutrons, and they would, I forgot the word now, but they would change into these fragments of the higher molecules, and with all varying half-lives. Some of them real fast and be gone a little bit, others be years, and everything in between. Well, then with the second test, it was an underwater test, and the bomb was in a caisson suspended between a landing craft, landing ship, medium LSM, and it was about 100 feet down in the lagoon. And we were much closer in on that one. We were out about 15 miles on the first one. When you evacuated the lagoon, we're out there on our net tender, the USS Shakamakson. It's an Indian name, and all these tugs had Indian names, Indian tribes and so on, their chiefs. And all the aircraft carriers were named after naval battles of the Revolutionary War of 1812 in those days. The Saratoga was a big battle, I guess. And Saratoga was a big carrier, one of our original carriers. It was converted from a battleship to a aircraft carrier right after World War I when they decided that naval air was here to stay. And but that was out there. There was a big ship, a very distinctive stack on it. And anyway, on the second one we came in, that was our first priority ship to board. And on the second one we came in, and we got up close to it, and it was listing kind of bad. And they told us to stand off and just circle it for a while. In about 20 minutes, it sunk. It reared up on one end and slid in the water and bubbled for quite a while. And we were watching it go down right beside it or back a ways, We weren't right beside it or anything. But it was quite a sight to be that close to a major naval vessel when it was going down. And one of the things I was out testing, I got assigned to jobs in between these tests. And one of them was to go out with work with divers. These were the hard hat divers. They had invented the compressed air cylinders in those days and scuba equipment. My job was to send electroscopes down with the divers and then retrieve them when they come back to see how much they did. And then I would check the stuff they would bring up. They would bring up parts of the ship or something. And they were diving on a destroyer the day I was there, and the Anderson, and they're taking pictures down there and so on. It wasn't real deep because this was all in the lagoon, which is a extinct volcano crater, basically, and it's coral reefs all the way around the rim, and with islands popping up here and there on this oval shape. Well, then I guess that was about it. After so many days of this, they decided that they were trying to clean the ships, but in the process, I got aboard the Pennsylvania, the Indiana battleship. Not the Indiana, Pennsylvania and the New York, and the Independence, the aircraft carrier, a couple times. That was in pretty bad shape, all twisted and torn, and fairly radioactive. And I was on all landing craft and troop transport ships, just about any kind of ship the Navy had, and even a dock. One of these docks you can submerge and blow out the tanks and raise the ship up, repair it, the smaller ships. And the bigger ones had to go to a port for that. But so finally they decided that it was over, and we were leaving, and they were just going to leave a few of the guys that had just got in the Army, young people, and they still had a few 6-8 months to go before they could be eligible to get out.
Okay, why don't you tell us, go back to a little bit on the ships that you explored.
Yeah, I got on all kinds of Navy ships, just about all kinds of landing craft and troop carriers, landing ships. They had ships as well as craft, as they call them, and destroyers, aircraft carriers, battleships, cruisers. I never got on any of the foreign ships. There were 2 Japanese, the Nagato and the Sakawa. The Nagato was one of a big super battleships that the Japanese had, and when we had 2 of them out there, And these ships were terrible shape. The crews that were on them were very unhappy. They were foul, they stunk. The sanitation was horrible. But then there was a German battle cruiser, one of these so-called pocket battleships, Prinz Eugen. That was the most beautiful ship you could imagine. Beautiful lines, very white, bright, just spotless. Good German engineering went into it. And I never got on board it, but some of the guys got on there. And, well, that was one of the things that they did was, believe it or not, battleships have wooden decks. And some aircraft carriers did even. A lot of the bigger ships had wooden decks. And the Prinz Eugen was no exception. It had a nice wooden floor. And when the bomb went off, it was so hot and that when it vaporized the steel from some of the ships that were real close, and they went up and there was a cloud, and when they got up a ways, they'd cool off and condense into little BBs, sort of, and small particles. And they'd come down on these ships. Well, most of them they'd roll right off, but on the Prinz Eugen, for instance, they fall on that wooden deck, and then they'd roll it. In between the boards, they'd seal them with tar, or some kind of a bitumen, anyway. And these hot BBs would go and they'd melt down into that. And they had to have the crew out there with knives trying to dig them out, and the guys, the radiation monitors, would find them with their Geiger counter and put a mark there, and then one of the sailors would go and dig it out. I don't know what they did with them, and that was kind of interesting. But the first test was similar to the ones in Nagasaki and Hiroshima in that they were airdrops, and with proximity fuses to set them go off when they got to a certain altitude. And this tremendous amount of heat that was generated would cause the air and the gases and everything from the product to expand, and so it would be real hot, and it would go up, and that's the traditional picture of the mushroom cloud, and goes up, and then as it gets up in the stratosphere, it spreads out and makes a mushroom shape. And it sucks all the radiation products, or not all of them, but most of them. All of the smaller atoms that are generated and when a nuclear reaction takes place. And they went right up with this in gaseous state at first and later condensed, but they still had this huge rising column of air. And then it gets up in the stratosphere, and then the winds start taking it, and it kind of dissipates and blows around the world, and they still could measure it all around the world. Well, that was the first one. So the first test was like testable, was that. The second test was a unique one. I guess the thought was that a submarine could come in your harbor and lay one of these things and then fire it remotely or something. And they wanted to see what effect it would have. Well, what it did, that tremendous amount of heat vaporized one heck of a lot of water. So it was a lot of steam. Plus, and that went up, and you've seen pictures of it, I'm sure. They're about a half-mile diameter column of water and spray and whatnot going up and sucking all this stuff up. And then it got up a ways to cool off, and a lot of it, the steam condensed, and it would come back down, and on the way down it would scrub some more of these radiation products. So they end up with a very radioactive rain coming down on the lagoon and on all the ships there. or would a harbor or a city or whatever. And it really would contaminate it with radiologically. So that made it so a lot of those ships were uninhabitable. They would come down on the steel ships and so on, and it would run off the water, but it'd leave a film always, and then this film would have all these radiological fragments in it. So, well, then they decided to go back. They were just going to give up trying to clean it. They're going to sink most of the ships and to send selected ones back to naval bases where they would look at them and scrap them or whatever, depending on how bad they were. And those were only the better ones, of course. The worst ones, they just took them out and sunk them. So there's quite a few of them on the bottom of the Bikini Lagoon. They took some of them over to Coagulate in the lagoon and sunk them there. And others they sank out in the open sea because they were declared surplus ships, and it would cost. Most of them were so radiologically poisoned that you could use them anyway. You couldn't have men working on them to dismantle them and for scrap even. So we got our group went on. Most of us, there was a few stayed. That the younger ones, but we were all got back on went on a troop carrier, the USS Enrico, and went back to Oakland. Stopped in Pearl Harbor on the way, both ways actually. Got a couple of days off there, and we got back to Oakland and took a train by a very circuitous route back to Oak Ridge, and we got in and about the evening, and we'd been about 4 days on this train going back, and the officer that was with us, in charge of us, an Army officer, he phoned to Oak Ridge and had him bring a bus down to Chattanooga where we were, because we couldn't get out of there by train till the next day. So we did. About midnight, the bus came from Oak Ridge, and we went back. And Oak Ridge was quite a bit different than the first time I was there. Nice dormitories, big, nice. You had rooms, 2 men to a room, and the first time we were there, we were in hutments. Just plywood buildings, about 12, no, more than that, about 16 feet square, and put 4 men in there, and they were heated by a stove, an oil stove that was fed from barrels on framework outside by gravity. And then the had windows, there weren't any windows, but you could lift the plywood up, and then it was screening under it, and you could put for ventilation in the summer, but in the winter, the only thing between you and the outside was about 3/4 inch of plywood, and there was cracks all around these panels that folded up, and they weren't weather stripped or anything. We just wood on wood and warped a little, and it was pretty cold, miserable weather, and it was all mud, boardwalks, and just to go to the latrine from one of those was a major expedition. And so the second time when we were there after the war, when it ended, and further get ready for after we came back, it was much more comfortable with all the nice shower rooms right next to one on each hall, and instead of having to go outdoors and walk away to go to the bathroom there. And the restaurant, the both times we had big mess halls that we ate in, but they were much better the second time around. But well, so then I got shipped out to Fort Bragg, North Carolina. We went up over the mountains, up over the road that went over the Smoky Mountains, and one that has a circular range to gain altitude. And I spent about 3 days at Fort Bragg and got separated, and I went home to Lansing. I flew from a Army field there at Fort Bragg over to Memphis. I was hoping I could get somewhere up in the Chicago area by government planes, but I couldn't. And so I went commercial from Memphis to Chicago, and Chicago to Michigan, Lansing. But the next morning, so I slept in a baggage rack that night in the airport. But I guess that's about it of that part of it. Then I went back to school, and we just got back in time. Michigan State started later than most of the schools, which was lucky because we didn't get back into the state till around Labor Day. And we didn't leave Bikini until the 15th of August. It's 2 weeks, about 5 or 6 days to Hawaii, and 5 or 6 more onto Oakland. And anyway, I got in time, but the classes were about ready to start. The registration always already taken place, but the assistant to the dean of engineering was a gal that we all loved. It had been, and she was especially taking care of her returned veterans that she'd known before the war, and so she arranged for us to get in the classes we needed and so on. And I went back to chemical engineering because I had the GI Bill now, so that helped. And I could still live at home. And our folks welcomed us back. My brother got back from Italy. He'd been the infantry over in Italy. And he was one of the beneficiaries of the bomb. His outfit was packing in early August, packing up in Italy getting ready to ship over to Guam or somewhere, get ready for the big one. And every once in a while I run into somebody, and I was in a Walmart down in Florida, and I ran into a guy that had been in the Pacific fighting, and he'd been in Philippines and so on. And he was in Guam then, and they were getting their equipment checked out and all ready to go. They were planning to invade in November. And he said, "You saved my life." So that made me feel, once in a while I get, somebody asked me if I felt guilty or something, because we killed so many Japanese, but we killed as many or more Germans in Hamburg and Dresden, just with conventional bombs and fire bombs. And sure, it was bad. War's hell to start with, and by sacrificing that number of Japanese, we saved 3 to 5 million more that we would have killed if we'd had to invade, because we'd have leveled everything with bombs first, and fire bombs, which were particularly vicious in the Japanese architecture. They had a lot of wood, paper, and stuff in their buildings, and burned like crazy. So, and we saved, of course, like 500,000 American lives, because the Japanese, we saw and seen how they fight. They didn't surrender. Very few surrendered. They'd fight till they were dead. And you had to burn everyone out of a foxhole with a flamethrower or something. And if they got in their home territory, it'd been even more so. And they were already arming the civilians with crude equipment and so on, obsolete but deadly. So it would have been a terrible situation. So anyway, then I got back to college. It took me 2 academic years to finish up. And the second year, in the summer in between, I got a job at Fisher Body, working. And then when the fall came, they only had gone back to 2 shifts with cars. They didn't need 3. And so it was a day shift, morning shift, and an afternoon shift, they called it. Went in about 4:30 or something. And they had a program there. Labor was short about that time, which most of the time it didn't seem like it wasn't. But they had this arrangement where you'd get another partner, another student, and work the evening shift all the time. And one guy would work Monday and Wednesday and every other Friday. The other guy Tuesday and Thursday and every other Friday. And that worked out pretty good. We each have about 20 hours on the average a week. And we were on the loading dock, unloading trucks, which was heavy work sometimes, but it was decent work. It wasn't bad. It was kind of cold in the winter sometimes, but so anyway, I had that money to supplement it, my money, and I been engaged to Jerry, and we decided to wait to get married till I finished, because she was teaching. She got out. I started a year before she did. She got out 3 years before I did. So she was teaching in Battle Creek, and then when we got married, in '48, she got a job in Kalamazoo because I'd taken a job at the Upjohn Company in a pharmaceutical firm in Kalamazoo, which is about 30 miles west of Battle Creek. And I started in and worked for about 9 years as a development engineer, developing and scaling up new synthetic processes. Upjohn was just getting into the synthetic drug business, and they had a big research for staff working for new products, and our job was to take these syntheses and make them safe and efficient, cost effective, and work at a larger scale, and then build plants and help the production guys start those up and so on. And so anyway, that's what I did that for 9 years. I got transferred to the fermentation area, and I was a research manager there, the fermentation pilot plant, where we made all your antibiotics and all of the steroids. Upjohn was a primary leader in the steroid business because we developed a biological way of putting an oxygen into a basic sterol formulation and molecule, I guess I should say, and to make cortisone, hydrocortisone, prednisolone. Then we developed a lot of specialty items, 6-methylprednisolone, and there was Medrol, and I'm still benefiting from that. I get a shot at once a year of Medrol in my left knee. Can you imagine? It's been since we were working on it at the time in 1958. And they're still using it. Most drugs that old are supplanted by better drugs, but that one's still going strong. And after about a number of years there, I did a lot of converting processes to being controlled with computer techniques where we'd make a mathematical model and then use a computer. We would develop new steroids, and we develop other pharmaceutical firms would develop their own special steroid, and they'd have us make it up to about the last step or two, and then they'd want to do their own finishing steps to get it to their particular product, because we kind of had the world by the tail for a long time there with a basic using soy sterols as starting material. Originally, all the steroids came from bile acids from cattle, but there wasn't enough to go around really. And then they started doing it with from diasgenin, which they got it from a root, some kind of a root that grew in the wilds down in Central America. They stripped the jungles down there. That was other people did. We didn't do that because we were able to start using soy sterols, actually from part of the product that they didn't use. So that was pretty good. And we did a lot of work and good work. And then after about about another 15 years there, 10 years more after that, I guess, I got transferred back to the head the chemical as a research manager of the chemical engineering development group where the synthetic drugs were made. And I was manager of that for the next 10 years. And the last 5 years, I was the director of chemical production at Upjohn. And I retired in 1988 after 40 years at Upjohn, which is unusual. People don't do that anymore. And I did a lot of good, interesting projects. I worked on everything you can imagine, Xanax and Halcyon, Motrin, Medrol, I mentioned that, but all kinds of drugs. Of course, right after I left, fortunately it was after I left, they started merging with a Swedish firm, and then Pfizer bought both firms, and the first thing they did was shut down most of the buildings and fired 1,500 researchers, and they continued to maintain the production of the products that Upjohn had. That's what they wanted. They wanted the products and the facilities to make it. And they weren't, because they already had their own research. They didn't need Upjohn's research. But so a lot of my friends lost their jobs right away. So I got out just in time. And my wife and I had decided before that we were going to start traveling a lot when we retired, and we did. We traveled all over the world.